Example 1. List all the properties of the angles, diagonals, and sides of a rhombus. So, starting off with the word rhombus, the definition of rhombus is a rhombus is a parallelogram with all sides congruent. That's the definition. So again, it's immediately a parallelogram, so immediately all the parallelogram properties come into play. If they're exactly the same property, I'm going to write it down. If the rhombus gets a more specific property based on it, so the diagonals bisect each other, maybe something else happens with the diagonals. All right. So if there's a more specific thing that happens, we're going to list that in this list here too. So I don't want to list all the parallelogram properties. I'm going to look at each one, and if they're the same, fine. If they're slightly different, but you know, we can use them, we're going to run them down. So first off, let's just start with the basic definition. A rhombus is a parallelogram, all sides congruent. That tells me that AB, BC, CD, and AD are the same measure. So the first property I'm going to write down for a rhombus, and again, it'll say this object is a rhombus. The first property I'm going to list is all sides are congruent. Now, real quick, just thinking back to our parallelogram section that we just did a moment ago, like last couple days. If both pairs of opposite sides are congruent, it's a parallelogram, right? So notice if you have any quadrilateral with all four sides being marked equal, this pair of opposite sides is congruent, that pair of opposite sides is congruent. That makes it a parallelogram immediately, right? And already all four sides are marked equal. So if you see a picture that looks like this, and they don't tell you it's a rhombus, but they say all four sides are the same, it's immediately a rhombus. So all these properties are going to come into play at that point. The second thing I'm going to look at is the diagonals. Okay, the diagonals are AC and BD. Going back to the parallelogram property, they bisect each other, right? So in a rhombus, they still bisect each other. So I know that this piece is equal to this piece, if this is the midpoint right here. And this piece is equal to this piece, again, if that's the midpoint right there. So they do bisect each other. But more specifically, not only do they bisect each other, but every angle in the middle here, angle 1, angle 2, angle 3, and angle 4, are right angles. So not only do they bisect each other, but they're perpendicular bisectors of one another. So, number 2. The diagonals are perpendicular bisectors of one another. They are not necessarily the same length. All right? This diagonal does not have to equal that diagonal length. These two pieces here don't have to match those two pieces there, but these four angles in the middle will definitely be right angles if it's a rhombus. Okay, so cut it in half just like a parallelogram, but right angles. A parallelogram does not require right angles in the middle. Other thing about diagonals. Well, let me jump to angles first before I get to the diagonal, the other thing about diagonals. Okay. Just like a parallelogram, the opposite angles are congruent. So let me get a color here. So angle A is going to be congruent to angle C, and angle B is going to be congruent to angle D. I'm talking about the entire, so BAD angle A, ADC angle D. So the entire angle equals the entire angle equals the entire angle. So they're not the same necessarily. These don't have to equal each other, but these have to equal each other, those have to equal each other. So number 3, the opposite angles at each vertex are congruent. Just like a parallelogram, the consecutive angles at each vertex, for example, angle A and D, angle D and C, angle C and B, or angle B and A, those are supplementary. So the consecutive angles at each vertex are supplementary. Just like all these other properties we've dealt with, these allow us to write equations. If you're given two opposite angles, one equals the other. If you're given two pieces of a diagonal, the same diagonal, one equals the other. If you're given two consecutive angles, one plus the other equals 180. So again, we're applying the properties to create equations based on the objects in the picture. Okay, getting back to our diagonals again, this angle equals this angle. This diagonal cuts this angle and this angle in half. This is an angle bisector as well as a perpendicular bisector. So not only is this piece equal to this piece, and those are a bunch of right angles, but this angle here is congruent to this angle here, and they're both congruent to these angles here because those two initial angles are equal. So, for example, if this angle here is 80 degrees, 40 and 40, that gets cut in half. If that's 80, this is 80, so this is also 40 and 40. So all four of these angles, these little tiny angles, are the same measure. And the same up here. This angle up here is going to be cut in half. This angle down here is cut in half. And again, they start off as the same angle, so their halves are the same. If that's 100, that's 50, that's 50. That's 100, that's 50, that's 50. So, number 5, the diagonals bisect the vertex angles. So in a parallelogram, that did not happen. Okay, the angles did not get bisected in a parallelogram. So again, all the same rules that happen, because again, parallelogram, these equal each other, those equal each other, those added to 180, those added to 180, and so on. These sides were the same, those sides were the same. Opposite sides are parallel. I didn't write that one down, but they are, right? So every property, but again, they're more specialized. Perpendicular bisectors, not just bisectors. Angle bisectors. The other one didn't have angle bisectors. All right. So keep that in mind. This is your list for a rhombus. So anytime you're told something is a rhombus, you're allowed to immediately assume all this stuff to be true because those properties are true for all rhombus.